carries flavor, conducts heat, and provides essential energy for billions. But where does this golden liquid truly come from? How do we get a shelf-stable golden liquid from a hard, dirty seed or a fleshy fruit? It's a marvel of chemical engineering. Today we document the entire life cycle of edible oil. The world consumes over 200 million metric tons of vegetable oils annually. It's a volume game where palm oil leads the pack, followed by soybean, rapeseed, and sunflower. It's not just food, it's politics, energy, and global economics. For palm oil, speed is critical. Once cut, enzymatic activity begins immediately. It must reach the mill within 24 hours. For seeds like soy or sunflower, the challenge is storage. Seeds are dried to low moisture levels to prevent mold during storage. The journey continues at the seed crush facility where cleaning and preparation are paramount. Step 1. Cleaning. We remove every impurity. Sticks, stones, and dust are separated before the real work begins. Huge magnets pull out stray metal. You can't just squeeze a dirty seed. Precision starts here. Next is dehulling. We crack the seed and use air to blow away the shells. We want the meat, not the fiber. Then comes flaking. Rollers crush the seeds into thin flakes to increase surface area. This is essential for extraction. This crude oil isn't ready for your pan. It's dark, cloudy, and smells like wet cardboard. We need to refine it. Mechanical pressing, or cold pressing, uses thousands of pounds of pressure to squeeze the oil out physically. It retains natural flavors but is inefficient, leaving up to 14% of the oil trapped. In this industry, that's a loss big players can't afford. Enter solvent extraction. This is where the big players operate, using chemistry to achieve 99% efficiency. They use hexane, a petroleum byproduct. Hexane is like a magnet for oil. It dissolves the fat while ignoring the fiber. In the extractor, flakes are washed in a hexane rain. The result is micella, a mixture of oil and solvent. To separate them, we boil the micella. Hexane vaporizes at 69 degrees C, leaving behind the crude vegetable oil. The hexane is captured, condensed, and recycled. Efficiency is the name of the game here. This crude oil isn't ready for your pan. It's dark, cloudy, and smells like wet cardboard. We need to refine it. First, degumming. We add phosphoric acid. The gums attract the water and swell, becoming heavy and easy to remove. High-speed centrifuges spin the oil. The heavy gums fly out. The lighter oil stays. These gums are turned into lecithin. Next is neutralization. We add sodium hydroxide to bind with free fatty acids, literally turning them into soap. This soap stock is removed and sold. The oil is now neutral, but still contains pigments that we need to address. For color, we use bleaching. But we don't use bleach. We use bentonite clay to absorb pigments like chlorophyll. The clay acts like a sponge, soaking up color and metal traces. Then, it's filtered out, leaving a light yellow liquid. The oil passes through pressure filters. What remains is clear, but it still smells like raw seeds or chemicals. The final and most critical step, deodorization. The oil enters a massive vacuum tower where superheated steam rises. At 240 degrees Celsius, steam strips away volatile odor compounds. The vacuum prevents the oil from burning. What emerges is RBD oil, refined, bleached, and deodorized. It's now tasteless, odorless, and perfectly clear. But some oils, like sunflower, contain waxes. If you put them in a fridge, they get cloudy. We need winterization. We cool the oil slowly to crystallize those waxes and filter them out. Now your oil stays clear even in the cold. For palm oil, we use fractionation. We separate it into stearin, the solid part, and olin, the liquid cooking oil. Stearin is the backbone of margarine and shortening, while olin is the liquid oil you find in your kitchen. Next is bottling. Bottles are blown from preforms at a rate of 30,000 per hour, ready for the filling stations. The oil is pumped in with extreme accuracy. Every bottle is filled to the exact milliliter in a fraction of a second. A drop of liquid nitrogen is added. It expands, pushing out oxygen to prevent rancidity and pressurizing the bottle for stacking. Caps are applied and labels are stuck. The oil is finally ready for the global supply chain. We've traveled through acts of harvest, extraction, and purification. We've seen the science and the scale, but we can't ignore the environmental cost. Deforestation, particularly with palm oil, is a major global concern. The industry is shifting toward traceability. Every bottle must prove it didn't come from a cleared rainforest. From here, it's a journey of global logistics, crossing oceans to reach every supermarket on the planet. Thousands of trucks move this liquid gold across continents, ensuring a steady supply for billions of people. The scale of this operation is almost unfathomable, involving millions of people and millions of tons of material. Finally, it reaches your kitchen. It's the silent partner in every meal, the medium that transforms raw ingredients. Whether it's stir-frying in Asia or deep-frying in America, the chemical properties of this liquid are what make it possible. But it's not just food. Vegetable oil is also energy. Millions of tons are diverted to create biodiesel for transportation. As the world looks for greener alternatives, the role of edible oil in the energy sector continues to grow. It's also in your soap, your cosmetics, and your industrial lubricants. Edible oil truly is the invisible backbone of modern life. Without these fats, the machinery of our civilization would literally grind to a halt. It is essential. What's next? Lab-grown fats and algae-based oils are on the horizon, aiming to solve the sustainability crisis. These technologies promise the same clear, golden liquid with a fraction of the land and water usage. The future is bright. In every refinery, quality control is a 24-hour job. Samples are tested for acidity, color, and peroxide value. Nothing leaves the plant without meeting strict international standards for safety and purity. Your health depends on it. Behind every bottle is a global workforce of millions. Engineers, chemists, farmers, and drivers working in sync. It is a testament to human ingenuity and our ability to organize on a truly massive, planetary scale. So, the next time you hold a bottle of oil, remember its journey. From a sun-drenched field to a high-tech lab, it is a story of transformation, turning nature's raw energy into a clear, versatile, and essential staple of life. It brings us together around the dinner table, fueling our bodies and our traditions for generations. From the smallest home kitchen to the largest industrial bakery, the ripple effects of this industry are everywhere. We've traveled through acts of harvest, extraction, and purification. We've seen the science and the scale. I hope this deep dive gave you a new perspective on the invisible fuel of our civilization. Knowledge is power. Stay curious and keep exploring the science behind the everyday. This is Simple Guyan, signing off. Thanks for watching this Simple Guyan Masterclass.